Conservation of momentum practice problem number 21. A 44.4 kilos cart is moving to the right at 12.8 meters per second and collides with a 22.4 kilos cart at rest and a 36.5 kilos cart that was moving to the left at 4.44 meters per second. After the collision, the first two carts stop, and what is the velocity of the third cart? So let's start by drawing a diagram. So here we have a cart. Let's draw represented by a box, a small box. So that's the cart A, which is moving to the right with a velocity, and then we have a cart B, which was at rest, and then we have a cart C, which was moving to the left with some speed. So that is before collision. After all three cars collided, we have here a different story. The cart A and the cart B, let's do this way, let's do about like this. There you go. So let's say that cart A and B, they came to a rest, so they stop, and the cart C kept going. So here is a arbitrary direction. We really don't know. The problem does not state the direction the cart C was moving. So let's just assume that it's going that way, but we don't know. What we know is there is two parts of this story. One is before collision, and another one is after collision. So we can apply conservation of momentum. So before we set up our big table and find what we are looking for, let's set up a data table with all this information. So let's start with the mass of cart A is 44.4 kilos. Mass of the cart B is 22.4 kilos. And the mass of the cart C is 36.5 kilos. Momentum, the formula for momentum is P represents momentum, lowercase, mass times velocity. So we have mass, now we need velocity. So when we use conservation of momentum, which means whatever happened before and after, they are equal, momentum is conserved. So we need to identify initial and final velocity. So let's here identify initial velocity for A is moving to the right at 12.8 meters per second. And the final velocity for A is 0 because it's going to stop. Initial velocity of cart B is 0. And the final velocity is also 0. Initial velocity for the cart C and our final velocity for the cart C. The initial velocity for the cart C is 5.44, but it says to the left will be negative as a reference. And my final velocity for the C, I don't know, so let's just repeat here. That's what we are looking for. So now we are going to set up our table with the first row for kind of title and each row for each object. A, B, C, and the last one is our total. So making the table make it way easier to answer this problem. There you go. So object, this is before collision, so momentum before collision. So this is our table with initial and final momentum. So this is object A, B, C, and that will be my total. So here is MA, VAI, MB, VBI, MC, VCI. Likewise, MA, VAF, VBF, and MC, VCF. So the mass for A is 44.4 times the velocity, initial velocity for A is 12.8. For B, the mass is 22.4 times 0. And for C is, the mass for C is 36.5 kilos times the velocity for C is negative 5.44. For final, we have 4.4 times 0 because is the final velocity for A is 0. B is 22.4 times also 0. And C is 36.5 times VCF. So now we are going to multiply the partial sections, 44.4 times 12.8. This is 0, and this will be negative 36.5 times 5.44. So here we have 369.76. From this side, we have 0, 0, and 36.5 VCF. Now, conservation of momentum states the initial momentum is equal to the final momentum. So the initial momentum is 369.76, and the final momentum is 36.5 VCF. So now we divide both terms by 36.5. So VCF is equal 369.76 divided by 36.5. So the final velocity for cart C is 10.13 meters per second. In terms of direction, since we adopted the positive going to the right, so probably the direction of the cart C, instead of going to the left, was going to the right.